हरि करना।
Now it's time to deep dive into the CDF, Cumulative Distribution Function. In probability theory and statistics, the cumulative distribution function is a function that describes the probability distribution of a random variable. The CDF gives the probability that the value of the random variable is less than or equal to a given value. And the most importantly, it gives the cumulative probability of x, capital X, that's the random variable, up to the value small x. The CDF is denoted by capital F of x and is defined as follows. Capital F of x is equals to P of capital X, the random variable, less than or equal to small x, that is any value. So the CDF, where in this equation, where small x is any real number and probability of capital X less than or equals to x is the probability that x takes on a value less than or equal to small x. So the CDF has several properties. The CDF is a non-decreasing function, which means f of x2 greater than or equals to f of x1 if x2 greater than or equals to x1. And similarly, f of x1 less than or equals to f of x2 whenever x1 less than or equals to x2. And second point, the CDF is a right continuous function, which means the limit of f of x the limit of f of x as x approaches from the right exists and is equal to f of a. So if you put it in mathematical notation, limit 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 x tends to x plus of f of x equal to will become f of x for all x. So the CDF is a non is the CDF is normalized to 0 at negative infinity and at 1 at positive infinity. So for a discrete random variable, the CDF can be expressed as an integral. For a discrete random variable, the CDF can be expressed as a step function. The value of the CDF at a particular value of the x is the sum of the probabilities of all possible values less than or equal to x. But when it comes to a continuous random variable, because this can be applied even to the continuous random variable, so for a continuous random variable, the CDF, the cumulative distribution function, can be expressed as an integral of the probability density function PDF of the variable. Okay, let's take one example. We'll see both parallelly. We'll see PMF and then CDF with the same example. Okay, so the example is rolling a single fair dice. So when you roll a single fair dice, what would be your probability mass function and what would be your probability cumulative distribution function? Let's see the probability mass function. For that, okay, so probability of x is equals to 1 is 1 divided by 6. X is equals to 2 is again 1 divided by 6, and x is equals to 3, again 1 divided by 6. X is equals to small x. These are the small x values and these are the probability of x's, probability of x. So probability of 1 is 1 by 6, probability of 2 1 by 6, probability of 3 1 by 6, probability of 4 1 by 6, probability of 5 1 by 6, probability of 6 1 by 6. And after plotting a graph, so this is how it looks. 1 by 6 1 by 6 1 by 6, this is what is your probability mass function. And if you sum it up all, probability is 1 by 6 plus 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 1 by 6. You'll get 6 by 6 and it's equal to 1. That's your probability mass function. Now let's use the same experiment, same random experiment to draw a probability, so cumulative distribution function, and see. So rolling a single fair dice, and this is what had happened. So P of x less than or equals to a respective value. So P of x less than or equals to 1, that's 1 by 6. Now P of x less than or equals to 2. Now it has to accumulate, it has to cumulative with the previous event also, that's 1. So 1 by 6 plus 1 by 6, it has become a 2 by 6. Then when it comes to 3, now I need to have till 3. So P of x less than or equals to 3 means from 1 till 3. So I have to add up all those things. 1 by 6 plus 2 by 6, it will become 3 by 6. Same when it comes to the probability of x less than or equals to 4, it has become 4 by 6, then 5 by 6, then finally 6 by 6. This is your cumulative distribution. Now if you plot it on the graph, and this is what you get. For x less than or equals to 1, this portion; x less than or equals to 2, this portion; x less than or equals to 3, this portion; x less than or equals to 4, this portion; x less than or equal to 5, this portion; and x less than or equals to 6, this portion. And it's cumulatively increasing, and this is what the main difference between a probability mass function and cumulative distribution function. Let's see the exact difference between each other in next slide.